In this video, I'm going to be describing how inverse trig functions work. We'll look at their possible graphs or their possible domains and ranges, and how to not get undefined answers when we try and use them. So the first thing we're going to talk about is an inverse sine function. This little -1, it kind of looks like an exponent here. That's the symbol for inverse. And we think about inverses as backwards trig functions. So usually when I take the sine of a function, I get a y value that corresponds on my unit circle. But if I think about the inverse of a sine function, then I would usually be given that y value, say it's 1/2 for example. And now the inverse sine is going to give me the angle that corresponds with this y value. So inverse trig functions describe angle measurements, either in radians or degrees. So let's look at the inverse sine function. We know that the coordinate right here on our unit circle is 0, 1. And the coordinate down here is 0, -1. Well, everything on the right side, the right hemisphere of this circle, are all possible values for an inverse sine function. We don't look at the left side. Over here would be all undefined possibilities for inverse sine. If you try on your calculator to take the inverse sine of, say, 120 degrees, it will give you an error or say undefined, because 120 degrees is over here, and that is not part of our domain or range in this graph of our inverse sine. Also, if you were to try and take the inverse sine of any angle that would be over here, that would be more than 180, in between 180 and 270. So if you tried to take the inverse sine of, let's say, 200 degrees, again, it would give you an error or undefined. So the only possibilities for inverse sine are in between -90 degrees and positive 90 degrees. So everything from down here at -90 all the way up to positive 90, we could write the same thing in terms of radians. It's the exact same statement. This has to be in between -π/2 and positive π/2. So those are the only possible options for inverse sine. Alright, let's talk about the inverse cosine here. So the inverse cosine symbol looks like that. And the possible values for inverse cosine are going to be in the first two quadrants, so quadrant 1 and quadrant 2. So this coordinate over here would be -1, 0. And this coordinate over here would be +1, 0. And everything in these two quadrants is a possible cosine value. We can't have anything in quadrant 3 or 4. So on your calculator, if you want to experiment, try and take the inverse cosine of 200 degrees and it will say undefined. Similarly, if you tried the inverse cosine of 300 degrees, which would be in quadrant 4 here, it would also not allow you to do that. So these are the only possibilities. From 0, either degrees or radians, over to 180 degrees or 1π radians. So 0 over to 180 degrees, or in terms of radians, 0 radians over to pi, 1π. So those are the only possible inverse cosine values. Alright, let's talk about tangent. Inverse tan looks like that. And this is a little bit different because tangent is a ratio comparing the vertical to the horizontal lengths. If this ratio gives you any kind of real number, then you can find the inverse tangent of it. But the value that you get when you take the inverse tangent of this ratio will only be in between negative 90 and positive 90 degrees. However, it can't be equal to 90 or negative 90, and I'm going to show you why in a sec here. So if we got our coordinates here, that would be a 0, positive 1 up there, and a 0, negative 1 down here. If I write the ratio of the y and the x value here, what I end up getting is 1 over 0. Now this is not a real number because this is an undefined ratio. It's an undefined fraction. Anytime you have 0 in the denominator, it's undefined. So I can't say that I can have an inverse tangent at 90 degrees or pi over 2, because at that exact spot it's undefined. Similarly down here, if I set up the ratio of y over x, I get negative 1 over 0, which is still undefined. Undefined. Let's spell it right. There we go. So my possible angle measurements that I get from an inverse tangent function are everything in between negative 90 and 90, but not including. So what I can do is write without the or equal right there. So any angle measurement in between those possibilities. Okay. Do the same thing with radians. Any angle measurement in between either negative pi over 2 and pi over 2, or negative 90 degrees and positive 90 degrees. So we cannot include those measurements, but everything else in between are possible angle measurements given by inverse tangent functions. Alright, so let's do some examples, see how we can apply this knowledge now. Let's try and find the inverse sine of the square root of 3 over 2. First few examples we're going to do are just going to be straight from our unit circle, and then we can use the calculator for a few examples as well. I want us to start thinking backwards here. So sine is going to be a possible y value. So if I think about my coordinate pairs that have a positive square root of 3 over 2 y value, I got two options. I got positive 1/2 as an x value, but I also have negative 1/2 as a possible x value. So there's two coordinate pairs that have a y value or a sine value of the square root of 3 over 2. But if I remember what the possibilities are on my unit circle here for inverse sine, there's only going to be one option. So 1/2 square root of 3 over 2 is about here. And if I think about the angle that corresponds, think about reference angles or just original angles here, that would be 60 degrees or pi over 3. And then if I want to think about the angle that corresponds with this coordinate pair, I got a negative x value, positive y, so I'm going to be over somewhere over here. Just sketching. So that would correspond with the same reference angle. But if I think about the actual angle, the angle that goes from here in standard position all the way over to there, that would be a 2 pi over 3, or 120 degrees, right? But the possible inverse sine values are only in quadrants 1 and 4. So this is not a possibility, and if you try it on your calculator, you try and take the inverse sine of 120 degrees, it's not going to work for you. So this is my only option. So I know that the inverse sine of square root of 3 over 2 corresponds with either 60 degrees or pi over 3. And if you use your calculator in degrees or radians, it should give you one of those values. Alright, let's do another one. This time let's try the inverse cosine of -1. Well, -1 as an x value, because it's cosine, would be this spot right over here, -1, 0. So I know that this doesn't happen. I don't get a -1 x value anywhere else on my circle, so there's only one option here. So the inverse cosine of -1 is either 180 degrees or 1 pi, depending on what mode your calculator is set to. So you can try them out, see if you get the same answer. Let's try another one. This time I'm going to try and trick you. Negative cosine of 2. So if we think about it, we don't ever on our unit circle ever see an x value of 2. It goes from +1 to -1. And the same thing with our y values. They go from -1 to +1 here. So I never even reach 2 if I'm talking about a unit circle here. And actually, if you use your calculator to try and find this, it will tell you it's undefined as well. This is just outside of the possible cosine domain here. All the possible x values should be in between -1 and +1, and this is outside that, so we would say this is undefined. Alright, let's do another. Let's try another one of these trickier ones here. The sine -1. So the inverse sine of 0, let's see where that happens. So we're looking for y values that are 0. Well, right here we have a y value that's 0. Over here we have a y value that's 0. So there are two options. But if we think about where sine can be, sine can only be inverse values in this range here. So we know we're not going to be looking at that one. So the inverse sine of 0 has to correspond with either 0 degrees, 0 radians, or, and this is the trickier part, if we think about a full rotation, we could also end up at 360 degrees or 2 pi. Now again, the reason we cannot talk about that as being an answer is because it got out of our possible range values, right? So again, only possible range values for sine have to be in between -90 degrees and +90 degrees, or -pi/2 and +pi/2. So once we get angles that are greater than that, no longer possibilities. Alright, let's do one more example here, this time with tangent. Let's do tangent, inverse tangent of +1. Tangent's probably the trickier one, because you got to do a little bit of problem solving here, but we want a ratio, a y over x, y coordinate over an x coordinate that is equal to 1. Well, the only time that happens is if the y coordinate and the x coordinate are the exact same coordinate. And the only time you get coordinate pairs like that on a unit circle are if they are these values. Corresponds to a 45-degree angle or a pi/4 radian angle. So if we set that up as a ratio, that would be equal to 1. So the inverse tangent of 1 is going to correspond with a 45-degree angle. So about right there. Or in radians, it would be pi/4. Now you may also be thinking that would it also equal 1 if they're both negative, because a negative divided by a negative is equal to a +1. So if we change these coordinates and now have a -x and a -y, that would be sitting over in this quadrant. That would be possible, but that is no longer in our tangent range. Alright, so that's not a possibility. Good luck playing with